smashing a building to bits doesn't take long. But even if you don't touch it, a building still won't last forever. The forces of nature will do the same thing eventually. This open-air theatre was built about 2,000 years ago. In that time, sun and wind and rain have eaten away solid stone, as you can see. 2,000 years may sound like a long time, but it's really nothing. This river has slowly sawn its way down through layers and layers of rock to create a deep canyon. It has literally removed all the rock. It took millions of years for all this to happen, and yet our Earth is even older than this. Over billions of years, the forces of water, wind and sun have changed the face of planet Earth. Water, wind and sun create a slow but relentless wear and tear, which flattens the landscape and creates soil. Soil allows trees and vegetation to grow. No soil, no plants. So without this process of wear and tear, plants couldn't grow on land. We wouldn't be here. Earth would be a rocky and hostile planet.
You can destroy rock in several ways. Here, I'm dissolving it in acid. Here, I'm heating it with a blowtorch. Or I can just grab my angle grinder and start grinding. Each of these ways of destroying rock has its counterpart in nature. All rain is slightly acid, which will dissolve rock, some faster than others. The flame is like the heat of the sun, working away to crack rock, and the angle grinder is the ice of a glacier, tearing away at it. Then, of course, there are rivers and streams, waves and wind wearing away at the rocks too. Eventually, they'll disintegrate and turn into tiny grains of sand or soil. This process has been going on for billions of years. It's slow, but powerful. Its first step is called weathering.
Weathering is the process of natural breakdown. Iron rusts, paint peels, pavement cracks. In fact, weathering will even get you in the end. First of all, there's chemical weathering. The oxygen in the air reacts with practically everything to oxidize it. Minerals containing iron are particularly affected, and that's the reason for the rusty red colour of so much of outback Australia. These very old rocks have had a long, long time to rust. Water is even more destructive. It dissolves almost anything given enough time. And as a chemical carrier, it has extra bite. Falling as rain, it dissolves carbon dioxide in the air and becomes a weak acid. These caves were carved out by the slightly acidic rainwater eating away the limestone. Of course, when the water evaporates, it leaves its chemical load behind, and that slowly builds stalactites and stalagmites. Water can also become acidic from contact with plants, from industrial pollution, and even volcanoes. This steam coming off lava pouring into the sea stings like battery acid. Then there's physical weathering, which breaks rocks by cracking them. Like most materials, rocks expand when they heat and contract when they cool. The outer layers are exposed to the greatest heating and cooling, so they tend to split off. They fall apart even quicker if the cracks are invaded by plant roots or by water freezing into ice. Or, as here, rock formed under pressure deep underground may expand slightly and crack on arrival at the surface.
Check this out. This is solid granite. You can hammer nails with it. And this is weathered granite. Look at it. It's been wrecked. Eventually, all rocks will turn into this. Basically, crumbled rock material which covers most of the land. It's called regolith. Obviously, bedrock is exposed in a number of places, like mountains, for example. But everywhere else, the regolith covers it, sometimes hundreds of metres deep. Now, whether or not we can call this soil depends on what's in it and whether it can support plant life or not. So, when we're talking about soil, what we're really talking about is the upper layer of the regolith.
For plants to get a hold on fresh regolith may take a while, but when they do, they add organic material or humus. This increases fertility. More plant roots break up more rocks, and ants and worms open up tiny paths, allowing more water, oxygen and carbon dioxide to get in. So where plants grow, weathering speeds up. Plants turn the top layer of regolith into genuine soil and make it thicker. You can see how this works where the soil has been cut through, as here on the edge of a cliff. Right at the top is a layer of decaying plant material, adding humus. Below is sand, then finer particles like clay, and finally at the bottom is the weathering bedrock. But if plants don't bind it, soil tends to get shifted and sorted according to the size of its particles. Wind may carry small particles like sand and dust, but it rarely moves gravel. Water is more powerful and may move larger pieces, smoothing and polishing them as they bounce along the bottom. But whatever the ways of movement, one force is behind it all: the all-powerful force of gravity.
Once this turns into this, it becomes really easy to move. Moving the products of weathering is called erosion. And where do they go? Downhill, of course. They almost always end up lower down. See, gravity drives erosion, and the ways it finds to do it are amazing. Even in underground water, dissolved minerals can flow like this. The plume slowly moves downhill because it's just slightly heavier than the rest of the water.
The most powerful agent of erosion is ice. As snow builds up on mountain peaks, it may slide off as a river of ice called a glacier. Slowly grinding its way downwards, the glacier carves out a valley for itself. It carries masses of ground-up rock down to the bottom, where the ice finally melts, turning into a fast-flowing river. The river carries huge quantities of newly made regolith all the way to the sea. These days, glaciers are not so common, but horizontal scars made by glaciers, such as on this cliff, can be found thousands of kilometres away from any ice, evidence that glaciers were once much more extensive. During the Ice Ages, vast areas had their soils made this way. However, not ice, but water as a liquid is erosion's biggest player. Less powerful, but much more common, liquid water has carved more rock and shifted more soil than any other form of erosion. Water runs off as rivers and streams, as well as soaking straight into the ground.
If you've ever built a sandcastle, you'll know quite a bit about groundwater and erosion. For a start, you'll know that if you use dry sand, the sandcastle won't stick together and can be just blown away. So, without enough water, soil can be carried away by wind erosion. With just the right amount of water, though, the sand becomes sticky. So, if you use damp sand, your sandcastle will stick together. So soil with the right amount of water in it becomes resistant to wind erosion. With too much water, however, the sand grains start to slip and slide, and the sandcastle falls apart. Whole hillsides have fallen down this way because the soil became too moist. Water in the soil is a critical factor in many landslides.
We don't usually think that erosion can kill people, But events like the Thredbo disaster show that it very definitely can. Here, part of the mountainside collapsed on the ski village. Equally devastating are floods. The brown colour of this floodwater shows the huge amount of soil and sediment that it's carrying. However, most running water moves safely as streams and rivers. They too will change the landscape, cutting it down or building it up. In the high places, they cut it down because in falling steeply, the water picks up speed and force and it carries particles away with it. Further down the slope, as the landscape flattens out, the river loses speed and tends to drop the particles on the bottom. Of course, it's at sea level where the river reaches its lowest point, so much of the sediment settles here. Estuaries and deltas tend to be rich ecosystems because thick layers of mud accumulate. Rivers are sediment sorting systems. The bottom of a mountain stream is gravelly because all the light sand and sediment has been washed away, while the bottom of an estuary is quiet and silty. This is where that fine material has finally come to rest. Although much sediment stays here, this is not the lowest place it may go. Sediments can flow right on out to sea. Ocean waves also chew away at the coast, shifting material to even lower levels. The softest soils and rocks go first, often leaving spectacular chunks behind, like these in Victoria called the 12 Apostles. But eventually these too will go, demolished by the sea.
So, with all this wear and tear, why doesn't the Earth just turn into one vast sea filled with sediment? It's because heat on the inside is constantly moving things. New lands and mountains are uplifted because of tectonic movement. And, amazingly, erosion can contribute to new uplift. When material is eroded from the surface, the weight is reduced, so the rock underneath is able to float up higher on the mantle. What, I hear you say? This is just a lump of wood floating in some water, but there are plenty of examples, just like this, where rock bends and folds and sags and deforms, just like a stiff liquid. So, gravity affects lots of things, given enough time.
And time is what Earth has had plenty of. Billions of years. Enough time, for example, for mountain ranges to vanish and for sediments to accumulate thousands of metres thick. Enough time for those same sediments to be pushed up to become new mountains. What once was sediment becomes rock again and starts yet another journey of erosion.
A huge amount of erosion is totally invisible. This water might look clear, but it's actually carrying a huge amount of dissolved material which will come out of the solution under the right conditions. Minerals come out of solution like this, all the time. And they're like strong glue. When soil and sediments get buried deeper and deeper, they get compressed and glued into sedimentary rock. So, the bottom line is, even though wear and tear produces all of the soil that supports our lives, eventually it will all be recycled back into rock. It's part of an even bigger story. The endless cycle of all the rock on Earth.
For a custom copy of this program, contact ABC Commercial on 1300 650 587 or visit abc.net.au/program sales.